Hey there, Mike.
Hey, can you hear me?
Yes.
Yeah, I don't necessarily like my background, but I'll stick with it unless you want to see my basement.
It's fine. I mean, your blue jacket is bringing the theme together. Okay. So let's go ahead and get started. Welcome back, everyone. I'm glad to see we still have good attendance here. Mike is from Cornelis Networks. He's a Linux kernel developer there and previously part of Intel, QLogic, and Silverstrom. He's been working on Omni-Path architecture for the last 8 years and with RDMA technologies for 15 years. He also has his bachelor's degree in computer science from the University of Delaware and master's degree from Villanova University. So Mike, tell us a little bit about the company. I think you guys are the new member company for OSA now. So tell us the history, how it got started maybe, and then dive into the presentation if that's okay.
That's fine. The company is actually not new. All of the members were spun off from Intel. So Intel basically funded and helped get us started as a separate organization. We have other external funding as well. I'm not sure how much I can get into. So we're essentially a bunch of ex-Intel people, and in fact, I see some of the old Intel people on the call. So
thank you. Thanks for
welcome.
that intro.
Hope that was good enough. So
that's good. Thank you.
So that's how the company came about. So if you want to.
All right. So yeah, the session here is you're going to talk about accelerated IP over InfiniBand. I mean, sorry, Omni-Path Architecture Advanced IP. Yeah, go ahead, please.
Yeah, accelerated IP. You'll notice the capital A and the capital IP are a little bit accentuated, just to say that where the acronym comes from. So if you want to skip to the next slide. Basically, we were living with the old native IP over IB verbs implementation. Probably that's inherited from InfiniBand. The MTU was limited to 4K for UD, and our OPA hardware actually supports 10K. We do have a connected mode which can tunnel packets through 64K RCQ pair, but it's got poor scaling characteristics. You end up with an n-squared situation, or at least a situation where your storage servers have to have Q pairs for all of the servers, its client servers that it uses to dole out storage resources. And it's got the additional overhead of the verbs layer, as well as IP over IB's inherent single queue for RX and TX, and it's a natural bottleneck. If you want to get any better than that on receiving, you need to use RSS to help spread the load across CPUs and get better bandwidth. That helps, but we struggled for years with this problem, trying to tune it for specific customers and getting around these issues. So if you want to skip to the next slide. So we have the hardware features we have in the chip. As I mentioned before, we have a 10K MTU, which helps the number of packets that are actually transmitting on the wire, although our link layer doesn't actually transmit packets, but that's another talk. We have 16 SDMA engines for sending packets, and we have 256 receive contexts available to us to receive packets coming off the wire. Now, the key feature here is our receive side matching capability that's in the chip. What that provides is it provides the capability of spreading packets across some number of the above 256 receive contexts, and it actually is the key to the effort. So we started this effort to explore these native chip features to get better performance over what the traditional IP over IB would give us. You can skip to the next slide. the core and IP over IB already had enhancements, many thanks to folks at Mellanox, for adding a capability to graft a network device onto IP over IB. So this data path is a tremendous boost to the performance by allowing more than a single queue on send and more than a single queue on receive. It still uses the UDQ pair and the rest of InfiniBand for multicast and pathing. So we said, okay, we said let's get with what the community is doing and exploit these native RDMA features. So skip to the next slide. So the first thing we needed to do was we needed to enhance IP over IB. So we had to add support there for a 10K MTU. The best practice is to have the FM control the MTU by specifying the multicast MTU size. And so then IP over IB will automatically, with its join, determine the MTU. So it allows us to control the MTU from a single point in the fabric, or multiple points if you're using a redundant FM. So we decided to extend the IP over IB with these relatively minor enhancements. Okay, skip to the next slide. So a high-level architecture picture for this looks like this. So we have some number of transmit queues. They're identical to the number of SDMA engines that you currently have configured. And on the receive side, we use the RSM rules to select IP over IB packets and then distribute them amongst some number of the receive contexts. Right now, that number is hard-coded to 8. Okay, skip to the next slide. So the key, as we said before, is the RSM. It's actually a programmable matching and spreading mechanism that's built into the HFI1 chip. You can use 2 fields to match, and then coming out of that matching algorithm, once that fires, you can produce an index using some kind of hash, and then index it into an array that has a base register, and then that points to one of our 256 receive contexts. The current index is in the DETH. We're actually using a reserved field there. And the upper entries in the map table contain the 8 NetDev contexts. As I said, those are the upper entries in the map. So that's the actual mechanism. It's quite elegant. It allows us to stare into packets and do this job. So it was actually pretty nice. Many thanks to Mark Debbage, if he's on for this. Skip to the next slide. So as we said, these are the actual code changes. So we added the minor changes in IP over IB. So we advertise in our capability mask that we can handle the special NetDev QPair create. And we added the support for transparently for the 10K MTU. The RDMA VT, which provides the upper layer for our hybrid driver between RDMA VT and HFI1, he advertises the use support up to the core. And then on the downside, when IP over IB creates a Q pair, a UDQ pair, he reacts to that and makes an adjustment in the QPN by putting a literal hex 8.1 in the upper 8 QPN bits. The code has to handle a restricted namespace from the normal 24-bit namespace, but for the purposes of a single on a single server with multiple Q pairs, or even a dual rail server, that's not a heinous restriction. So most of the changes we made were in the HFI1 driver. We added the TX and the RX code, and we added an additional context type. The other two context types were verbs and PSM contexts. In this case, we added a special case for a NetDev context. We also added the RSM rule that I documented in the prior slides. Now, the actual enhancements are upstream as of 5.7. There's a lot of people that worked on this project. If you're interested in looking for credits, you can look in the commits that went into 5.7 for the AIP stuff. Particularly, I'd like to mention Jim Wright, who actually was a pioneer in this. He did a lot of this prototyping work with the VNIC implementation that's currently upstream, and we borrowed heavily for that to get this effort underway. Okay. Next slide. Okay, these are the payload or the payoff for the effort. Before we did this, this is what we were seeing in terms of performance with heavily tuned systems, with IP over IB traffic going through a router. The particular hardware that was involved is listed. And you can see we can't even get to a high percentage of line rate. And this is with 4 streams. And adding more streams doesn't help. It tops out pretty quickly. Next slide. So once we implemented this and we had the spreading, you can see we get within a respectable percentage of what TCP would get with other technologies. So this is, we did 2 streams to get it, but as you can see, we can get it. So the use case for this this implementation really is router systems, where we switch between HFI1 OPA and some other technology like the 100 gig, 200 gig Ethernets, or even slower Ethernets. So you could see that the MTUs we used on either side, and it actually performs quite capably. Okay, next slide. Okay, so we're looking at some features for this implementation. We're looking at a zero copy feature where we'll use some page flipping techniques to replace context buffer pointers from a pool of available SKBs. This will be based on some percentage where smaller buffers will bounce the copy, other buffers will cycle the replacement SKB in place as we need it after it's been dispatched up the stack. So it'll essentially graft a pre-allocated buffer into the SKB as it processes each packet. We're also looking at a more flexible way to add RxQs, as I mentioned in the prior slide. We currently have 8 RxQs and it's hard-coded. To implement this, we're going to reserve some more map entries at the top end, and then round robin those entries on the receive context based on the current count. And so we'll add an ETH tool mechanism to reduce or increase these contexts as necessary, and then adjust the round robin in the map to in a secure way, atomic way, to make sure we don't misfire packets up the stack. Okay, so next slide. I think we're probably into questions. It's a pretty short presentation, to be honest. It's a pretty short implementation. There's not a lot of code here. A lot of it leverages IP over IB. As I said, it's now upstream. Many thanks to the people that worked on it. If you're curious, it's up there. You can see each commit. Please look at the commit history and see who the authors were. I won't take time. There's probably at least 9 or 10 that intensively worked on this project, and to be honest, they probably did a lot more of the work than me.
Thank you, Mark. Any questions for Mark, either through chat or you can bring it up now? Okay, I'll wait for a minute. That's fine.
Sure.
An awkward minute.
I'll take any questions there are. As I said, all the code is upstream. Everybody's welcome to take a look at it, comment in that forum.
Okay. Yeah, the one that's on the chat is from the previous session to JK. All right. So if no other questions, I will let Mike go. Thank you, Mike, for your time here today. I will keep monitoring the chat, and please, if you are here as well, take a look. If some question come later on, you can answer it through the chat.
Yeah, I'll stay on just in case. I may take off my off the video.
Yeah, definitely.
But I'll gladly answer any other questions. Thank you. Thanks, everybody.